Welcome to CW 8.3. Today we'll be talking about limações and how to use your calculator to analyze graphs like that. So start by opening our calculator, and we're going to go to Apps, and you want to hit Polar right there. The first thing we want to do is type in our first equation, which is 2 plus 3 cosine of theta. Now I'll go to Plot. And now we're seeing it draw. Yours might look a little bit different, but you can just watch my calculator. So here we can see it's drawing our curve. Notice how it's very similar to the graphs you worked with last time, except now you see this loop in the middle. So take a note of that picture. We're going to basically copy it down here. So there was a loop at about, actually I'll draw this in to make it a little more clear. Here's our XY axis. If I go back to my calculator screen, let's take a look again. It's going out to about 5 units on the right. It's the origin. The little loop is about 1 out. So let's put a dot here. So about 5 out, dot here. Loop, and then about 2 units up and down on the y-axis. 1 and 2. Okay, let's try to draw it. So very similar to the cardioid you worked with in the last lesson, except there's a loop right there. Okay, so there's our first graph right there. Okay, quite interesting. Now let's look at the next one. 3 plus 2 cosine theta. So let's go back to our calculator. We're going to switch the 3 and the 2. So I just went back to where I was before. We're going to switch this 3 with the 2. Take a look at the graph. So pretty similar, except we're seeing it's not looping, and it's also not hitting the origin. So it's kind of like a monopool in a way, kind of like a big blob. So let's graph that now. So it goes same distance, about 5. Comes up to here. And something like this. Comes out. And again, doesn't have to be perfect, but just try your best to draw these. Okay, so not great, but that will do. Let's do letter B. The difference between graph number 1 and number 2, what's happening there? So we can see that number 1 has a loop. And it hits the origin. Whereas number 2, I can see it doesn't do either of those. The question would be, why is that happening? If you think about it, the whole point of this is that this loop is happening because of these numbers. This number right here is smaller than this number, versus this number here is larger than this number. So when this happens, like this number is smaller, like 2 versus 3, there is a loop happening. But here, we can see it's not happening. So more deeply, why would that be? Well, that's because the range of cosine, or any cosine function, is -1 to 1. Which means, if you think about this thing could be any number from -1 to 1. Which means this quantity has the potential to be negative. And that negative is what is going to create this loop. Whereas this one, it's impossible to be negative because from -1 to 1, the smallest this could be is -1. And then if we plug that in, that'd be 3 plus 2 times -1 that'd be 1. So there would be no loop here. So in other words, think of it like a max and a min value. Max, min. The biggest this could be is 1, and that would occur at 0. So let's say r, or not r, theta equals 0. You plug that in, r would equal 5. That's our max, and we're going to see that right here. But the minimum we could make theta equal pi, because that would make -1, and that would make r -1. And this negative right here, that is what is creating this loop right there. Okay, so let's go down to b. If the form is a plus minus b cosine theta, what happens when a is bigger? What happens when b is bigger? So basically just kind of summed it up there. If a is larger, I mean the first number is bigger, there is no loop. And it won't hit the origin. If a is smaller, meaning b is bigger, there is a loop, and it hits the origin. How are a and b related? So this part's pretty simple. If you take the absolute value of each of these variables and add them, you get the max. If you subtract them, you get the min. And we're seeing that here, right? 2 plus 3, look at that, 5. 2 minus 3, -1, so that's pretty nice. What would happen if we change a plus to a minus? Okay, so let's try. 3 plus 2 cosine theta. Let's go to our calculator. Let's make that a minus. Think about what you think will happen, and let's see. So as we're watching this, think about your prediction, and it looks pretty clear. It reflected over the y-axis. So for E, we'll put reflects over the y-axis for this part. What if we made it a sine? So let's go back. This is a cosine graph. Let's change that. Let's put sine. And take a look. So notice how it's definitely different, and actually changed the orientation. The orientation is now going down. Or you can think of it as y-axis symmetry. So let's write that down. It changes orientation. To have y-axis symmetry. So these graphs are called limosons, and they're characterized right here. And we're going to try to do a couple together to make sure we got it down. So for this one, we'll make the equation r equals. The first thing you want to notice is, look at the way it's pointing. It's pointing in the x direction, or has x-axis symmetry. So at that point, we know it's going to be cosine theta. It's also on the positive end, so you're going to put plus. Now here's the part that's important. All we need are those two numbers that are left. What I like to do is to find this number first. This number is going to be what I call the intercepts, meaning this one or that one. So I can see that number is 3. And to get this last number, let's call this A and B, I know that a plus b must be the max. And in this case, the max is right here. The max is 6. So that must be 3. So let's try one more. R equals. I can see it's going up, so it's going to be a sign. It's also pointing in the positive direction, so you put a plus here. My intercepts are 2 out, so put 2. And here's the important part. The max is 6, which means our conclusion is this must be a 4. Okay, so try to finish the rest of the worksheet and let me know if you have any questions.